So, to start off, then this is the application for the product engineer position. A little bit about who I am. So my name is Mario Martinez, as I've already introduced myself before, and I've been with HP for the last 6 years. I've been providing support for 5 different products. We'll get into detail about what they are. My last rating on the focal point review was exceeded expectations, and so was the year before that. The agenda itself, like what I want to cover in this video, would be pretty much the key responsibilities that make a product engineer. I'm going to list them here. They've already been listed in the requirements for the position, so I'm going to get into each one. So the first one would be the using appropriate engineering tools and software packages to troubleshoot system hardware, firmware, components, and solutions. Now, currently I work with 5 different tools: Load Runner, Performance Center, Quality Center, also known as Application Lifecycle Management, Service Test, and Service Virtualization. Now, all of these are, in some way or another, pretty much engineering tools. The Load Runner is for quality testing, stress testing for particular websites and client server applications. Performance Center is just the same as Load Runner, but pretty much on a grander scale, where you're pretty much working with projects, and a lot of people are going to be using the same tool. So Performance Center, in some way of thinking, it's like Load Runner, but using several installations of Load Runner on a bigger scale, where you have multiple users, so you have to administer that. While ALM is also like a project tool, which now has been integrated with Performance Center. So they're now a single tool, and they pretty much, it's for the separation of projects and pretty much like rolling out like certain developments. And Service Test is for testing pretty much what would be web services. Service Virtualization is the same thing, but in a virtual environment. So all of these tools are integrated with Load Runner in one way or another. Other stuff that I want to be mentioning here is that I'm also like pretty much a hardware buff. And we work with, and where I used to work in Alienware, which is a high-end computer place that got sold to Dell. And we used to actually work with a lot of motherboards, a lot of sound cards, a lot of video cards, pretty much different hardware configurations. And it required doing like hardware updates, firmware updates. We also had to do RAIDs, different types of complicated setups, and a lot of hardware that actually came in. We had to learn it from scratch. And so I do want to show you, like, I do have my own machine that I've created myself. So, as I was mentioning, this is my machine. As you can see, I've created this machine myself. It uses a Thermaltake case, and it uses multiple fans because, well, indeed, it's sort of like a machine that requires a lot of air to be circulating. It uses a video card, which is a GeForce 660, which is mainly like a gaming, like sort of like setup. The processor is an Intel i5 quad-core processor, and I'm using an ASRock Extreme 4 like motherboard. All of these stuff was actually, I bought it, trying to make sure that it's actually integrated properly with the right chipset. And of course, like there's the memory that also, like, I forgot exactly what the timings were, but all of these things according to like power board. This is like the power supply. I have around 4 hard drives and a solid-state hard drive, along as with like one with card readers and like fan controls, and of course like the particular optical drive, which it's not currently used as much. But so as you can see, like, this is like sort of the things that I like to do. I do like to play a lot with hardware, so just to kind of like give you an idea. So moving on with the product engineer application, do have on the using strong analytical and problem-solving skills. I've been working like pretty much in doing troubleshooting for over 10 years, and I've been working particularly with also as a supervisor dealing with people. And currently, in my latest position, I'm working as a named assigned support engineer, which means that I'm assigned specific to an account to be able to work with them in order to resolve their issues. So I'm sort of like a dedicated resource that they have paid for. Prior to that, I was also working in like forums, pretty much doing monitoring there. But if you want to find out more, just let me know. Now, familiarity with server and computer architecture and diagnostic tools. We do currently work with a very vast array of like architectures, from different customers, and they normally have things set up differently, and they may have different things. So you can see here pretty much a basic architecture for a load runner. As you can see, it's composed of several things, several protocols, several servers, and things that you have to take into consideration: firewalls, routers, bandwidth, latency, and all just to be able to actually do a proper test. Then once you're able to check that, then you're able to identify also other things through the tools for like load testing. But if you want to find out more, just let me know. Moving on to the next one, which would be the familiarity with manufacturing of electronic systems, assemblies, components. So in order to be able to illustrate this, because this was one of the things you were worried about, was my knowledge of like electronic components. So I wanted to actually do an explanation here with an example. So I'm using this Linksys Cisco router BEFSR41 version 3, and it's an old router that I got like way back in 2001, I believe, and so I'm going to use it as an example. So I'm going to tell you first a little bit about it. It's a router. I already told you the model number. It supports the protocols for TCP/IP. On the speed, it's on 10 to 100 megabits per second, so that means like only it's the max speed that it's going to be able to use on cards that also support, like network cards that are also able to go to 100 megabits per second. And if they're able to do the 1,000 megabits per second, then either way it won't matter, because the router is only able to go 100 megabits per second. So it'll only go to whatever is the lowest. So if it's like a card that's only able to do 10 megabits per second, then it's only going to do 10. And the max speed would be 100 for the router. And for virtual private networks, it does support like IPsec and PBTP for encryption. Quality of service prioritization is based on port or service type. So basically, like whatever is actually the highest priority. Configurable as the HTTP server on your network. So basically, yeah, like it'll auto-assign like the IPs, which is always good. It also has to be supported within the OS, that it doesn't have a static IP. Advanced security management function for port filtering, MAC address filtering, and DMZ hosting, which is done within the software itself. So you would have to access like through like tool and go to the certain like 192.168.1.1, like which would be like the gateway address. So I'll go ahead and we'll move into what would be the disassembly. So this is the router. Now this, of course, it's the BEFSR41 version 3, because there's actually 4 revisions of this particular router. Now, as you can probably see here up in the front, we have like these indicator lights for each one of the Ethernet ports. As soon as like the port is connected, it lights up. Of course, we have like the internet connection. That in the back would be like the connection from the modem, and of course the power indicator telling us that it has power. Of course, in the back it has like the 4 ports and the internet port and the reset button. So I'll go ahead and begin what would be like disassembly. And well, here's the board. So after removing the plastic shell, this is what we have left, this particular circuit board. As you can tell, like it has this Cat45 connectors and the power connector and the reset switch. We have here, like, this is the part that takes care of the power. We have these 2 capacitors. One is of what is it? It's a G-Luxon of 25 volts, and this G-Luxon of 35 volts. And this particular, like the orange chip, the circuit choke, and this transistor. All of this takes care of power. We have these 2 line drivers, which actually define how long the signal can be able to be sent out from this particular router. So 1 line driver for 2 ports. Then we also have the internet port, which connects here. Then we have I don't know, this particular like what is it called, like a pulse transformer. Then we have like the processor, which we are able to actually program all the protocols in here, the TCP/IP, the UDP. Then we have the RAM. This is the RAM for the MAC address. and this is the RAM that pretty much, I guess, contains like the HCP stuff that once you actually connect, then it'll automatically assign the IPs. Then of course once you reset it or turn it off, it'll forget. And then yeah, pretty much that's it for this board. Then moving on with understanding the material properties and hardware and software and electrical component functionality. Material properties, I guess one way to explain it would be like the properties of the materials that we're going to be using themselves, like the strength, the durability, everything that actually goes into making maybe a good product, and trying to maybe see exactly how much it's going to cost to actually make it. So we're able to actually know like it's, I guess, it's the strength and durability, and like how like exposing it to certain like environments it might actually be like. Mainly that's why like you have like these bezels that have to be like resistant to certain types of hits and shocks, so it can actually protect what's inside. So we have that. Then there's of course the hardware. The hardware itself is all these things. Like, so we have like the transistors, we have the capacitors, these RJ45 jacks, well, these Cat5 jacks, and the processor, the RAM, these like line drivers that are going to be used as well. Everything here is hardware, and it's all going to be like made like be put together through like pretty much like the electrical components, the electrical engineering, and once it's connected in order to be able to actually like function. And we use software in order to be able to interact with it. So the software itself is the firmware, plus of course the software that we're going to use to program it in order to also be able to interact and be able to actually do certain functionalities with it. That's accessed through what would be like an operating system. So I'll be skipping over the last part, which would be the part where we analyze the empirical data, which I do believe is like the most important type of data because it's based on real-world information. But I know there are like processes probably for researching all of this stuff, and so I'll be skipping over it because also the video turned out to be a lot longer than I expected. So I do thank you if you took the time to actually listen to it. I would be grateful if this in some way helped me out in order to actually be able to get an interview. I would love to be able to show what I'm able to do in order to be able to help out what would be the supply chain organization, and of course the product family organization as well. Thank you so much.